record our session. All right. It's the answer to 5. Do you know?
No, I forgot how to do that actually.
Okay. Well,
Off the top of my head.
There's 2 actual ways to teach you how to do this. I'm inclined, to me, one can't really learn logs without starting here. Here's an exponential equation, okay? Now, there is an equivalent logarithmic expression to that equation. And you only have to remember one thing. Logs are exponents. What has to go on the other side of the equal sign?
The y.
Logs are exponents. Only one exponent.
X.
So I know that much for sure. Now, it's all I have to do is figure out where the b goes and where the y goes. Where's the b go? That's the base, right?
Yeah, it's base and then y.
There's only one other place left for the y. So to me, I use this memory technique to convert back and forth. And the real key is memorizing that logs are exponents. If you remember that logs are exponents, then you know the log of something, whatever's on the other side, is the exponent from the exponential equation.
Okay.
So let's take this exponential equation and write it.
So isn't it just log base 10 of 52 is 2x?
Uh-huh.
Okay.
Now, there is another way to think about doing this that gives you the same answer. And that would be taking the log base 10 of both sides. Well, what is log base 10 of 10 to the 2x equal?
I'm not sure. Log base
2x. Whenever the base is the same as the argument, then the answer is the exponent. So that turns into 2x, and I get log of 52, log base 10 of 50. So I get to this answer in one of 2 ways. I can either take the log of both sides using the base of whatever this number is, or I can just translate it based on this equivalency over here. Okay. Now, when you're faced with going the other direction, I have another little memory technique that I like, and that is I take the number on the far left, which is the base, e, I raise it to the number on the far right, which is 26b, and that is equal to what's the argument? Simple. Number on the far left raised to this equals the number in the middle, or the letter, either one.
Okay.
And now that might get you in trouble if you run into something that is written like this, which is just as true as number 6 is. And now my little memory technique doesn't work here, because now it's e, the number in the middle, to the number on the left equals the number on the right. So my technique works as long as the natural log is on the left side only.
Okay.
But nonetheless, you can always figure out what the rule is by making sure that is on the left side. and then just use the number that's furthest to the left is the base, raised to the power of the thing furthest to the right equals the thing in the middle. All right.
Okay.
Oh, more Newton's law of cooling. At least I got it memorized, I think. Do you? What's the general?
Oh, I have it written down. So U and then times T equals T plus.
Let's start with the far left side. And I remember that because that's pretty strange. You rarely see these two letters being the same. And they're not the same at all. The capital T is temperature, the little t is time. But how often do you see something like this? You just don't. So it's quite unusual to see something where you have two letters that are the same, one's capital and one's little, and they mean different things. So what's that equal to?
T and then or plus the initial temp minus
T of what? All of these have subscripts. T of the medium. Remember, we've got the original temperature and we've got the medium temperature. And it's minus, and over here we got T of the medium minus T of the original, or the starting. The rest of it?
And then it's times e to the power of kt.
I think it's minus kt. And only because I remember talking about that last time with you. I didn't know why they made it minus. And in fact, you'd be fine if you left it off. Because if you leave it off, when you solve it, you'll come up with a negative k. If you leave it on and you solve it, you'll come up with a positive k. So I have always been curious why it is there. There's got to be a reason. They wouldn't put an extra minus sign in there without reason. I just haven't figured out what it is. All right, so let's look at problem 15. Let's fill in everything. Answer the following. Find the decay constant. So the first thing they want us to do is solve for k. That means they're going to give us everything else. They're going to give us t, they're going to give us t sub m, t sub o, and t of t. That's the only way we could solve for k. Now, let's figure out what everything is. What's the 375?
Is that the t sub m?
Oh, T sub m is the T, or the temperature of the medium. T sub O is the original temperature.
Oh, okay.
So that's 375. Okay, so
and the t sub m is 60.
375. And what's the temperature of the medium?
Is that the 68?
Huh? So that's 68, and this is 68. After 10 minutes, the temperature is 300. What two things does that allow me to answer?
You can put your t in, or your time in.
Well, after 10 minutes, the temperature is 300.
You can do 300 times 10.
300 is the temperature after a period of time. And then the little t is 10 minutes. Or is it? Let's see. Yeah, I guess it is. And we don't need to. The important thing to remember on these units, because t is not always in minutes. T can be in days, t can be in months. The thing is that if I use a different unit, let's say I use seconds, then K is going to end up being different. This K that I come up with is only K if T is in minutes.
Mm-hmm.
All right, let's just make sure you know how to solve this. I can simplify it a little bit. Got 68 minus a negative 307
So isn't
times
that just 375?
to the minus K. Isn't that just what?
The 68 minus the negative 307, isn't it just 375?
No, because this is a multiplier of E. So
Oh, never mind then.
it's definitely going to turn into a plus number here, but I'm going to move the 68 to the other side first. In other words, you gotta make sure you do these by the correct order of operations when you're solving an equation. Anything that's being added or subtracted, and that's what the 68 is doing, it's being added to this equation, then I've got to subtract it first. And then I take whatever is multiplier and I divide by it. But I got to make sure I don't do that first, because the 68 is not a multiplier of the e to the minus k. What happened to my 10? Can I erase it?
I'm not sure.
I must have. Oh, I know. I went to erase minutes, and I think I erased the 10. So here's what we've got. We've got 232. I'm going to divide it by positive 307. And that is equal to e to the minus k10, or 10k. And now what's my next step?
Don't you take the natural log?
Huh?
Both?
And what's the right side become?
Like, well, for the answer for that is like 2.25.
Hold on. What does that become?
Oh, the right side. Oh, that just becomes negative k times 10.
Okay. And the left side, for the moment, leave it like that. And now, what is k going to be?
Huh?
In other words, I'm trying to solve for k, so I still have to divide both sides by minus 10.
Mm-hmm.
And that's k. With me?
Yep.
Now, if you were in a really high-level math class, they would never have you convert this to a decimal. That would be the answer. And
Okay.
if we go back into the original equation, this, well, I know what T sub m and T sub o are, and what I list for k is what I've got circled down there on the left. That's my k. And I can put it in like that. In other words, I don't have to round this off. I can leave it exactly like this. And then the next question is how long to take until the temperature is 100 degrees. And now I got to solve for T, but I'm using an exact K. I'm not using an approximation for K. Okay, I didn't see that. Okay, go ahead and round that off to 4 decimal places. What do you get?
Okay. I got negative 0.2257.
Okay, that is a positive number. Here's how I know.
Negative.
When you take the logs of numbers less than 1, you get a negative answer. So I'm going to have a negative numerator divided by a negative denominator. That is a positive number.
Okay. So it would just be that number in positive then.
Okay. What is that number? I'm sorry, I didn't write it down.
0.2257.
I heard negative and my mind stopped working. Okay. So that is K rounded off to 4 decimal places.
Mm-hmm.
Now, the next part, now that we have the equation, in other words, we know what the specific equation is for this model, and that specific equation, write it just so you're totally clear on it. It's T of T equals 68 minus 68 minus 375 e to the minus 0.2257t. Here is our specific equation regarding this loaf of bread and this oven and this medium temperature. So now we can answer any question you want to ask. What's the temperature going to be after an hour? We could answer that. Or if it says, when will the temperature equal 100? How do I solve that?
You replace the T on the left with 100.
Next step, we won't go through it all, unless you need to. If you need to come up with an answer, we can go through it all. But I'd rather get a little further along. These problems are complicated enough that we only get to about 2 of them a day, or 2 of them per session. And I'm 99% sure you know what the next step is here. Just tell me rather than doing it. What's the next thing I'm going to do?
Subtract that 68.
Okay.
Both sides.
And then what?
Let's see. You divide, or no.
Remember,
You get the 68 minus 375.
You're trying to isolate that. So yeah, so I divide everything by a positive
Yes.
307. Then what's the next step?
You take the natural log of both sides.
Okay. And I know you know what to do after that. So let's do another one. This is a good one. And this is a little different also. What's the general equation here? In other words, the moment you see a radioactive decay problem, it's not Newton's law of cooling for sure. What is it? What's the general equation?
I'm not sure.
PERT.
Okay.
The amount left is equal to PERT.
Okay.
Now, again, even on PERT, for decay, I've seen R with a negative sign in front of it, and actually called K. In other words, it's e to the minus kt. But I prefer this method. We'll come up with a negative R, I'm sure, merely because we're looking at decay. So how do I interpret this information that I've circled? How can I write an equation that basically says that? What does A have to be relative to P?
Half of it.
Okay. And you're going to see what happens. If I make A 1/2 P, look what happens. Doesn't matter what P is. It's going to cancel. And I'm going to use 5.3 years here. Well, because the P cancels, in other words, regardless of what that starting amount was, now I've got an equation I can solve. And I'm ready to take the natural log of both sides immediately. So it's the natural log of 1/2 divided by 5.3. That's what R is. Now, since that's going to be a negative numerator, we have a positive denominator. Go ahead and do that. Let's come up with what R is, but it's a negative.
I got negative 0.13.
All right. So now we know our equation. Our equation, the only part I have to plug in is the R. That is negative 0.13, and that equation works for cobalt 60. Regardless of how much cobalt you start with, in other words, no matter what P is, if you give a time, you'll be able to solve for A.
Mm-hmm.
The key is knowing that that P is going to cancel out, and you don't need the starting amount if they give you half-life. And all half-life problems are kind of like that. They don't even normally tell you the starting amount, but we're ready for it now. In other words, starting from this equation at the top, which is the equation for cobalt 60, I might add all cobalt 60 in the world would have this equation. They all are going to have the same half-life, which gives you an R of minus 0.13. So what do I do next? What will you have 1 year from now? Tell me what I should write.
Let's see. You got the 12.4 and then times E.
Hold on, give me the full equation, starting from the left.
Oh, A equals 12.4 times E to the power of negative 0.13 times 1.
Yes. The only thing you have to be careful is that they don't mix up the time units on you. In other words, if they'd have said 12 months from now, then we'd have had to make sure we convert those number of months into years. Because this that 0.13 is only if time is in years.
Mm-hmm.
And you can get that number out of your calculator. When will only 3 grams be left? What's my equation?
3 equals 12.4 E to the power of negative 0.13 times T.
How do I solve that?
You can divide the 12.4 off from both sides.
Okay.
Then you'll take the natural log of that.
Uh-huh. And I know you know how to do the rest of it.
Mm-hmm.
Okay, let's see. Do we have enough time to at least talk? Let's see if there's anything unusual about this last question. Yeah, we got time anyway. The half-life is 710 years for all silicon-32. Write an equation. When you were looking for the equation, there it was. It was on the page. We just didn't see it at the bottom. I actually wish they wouldn't have given you that. You don't need that. In other words, that's kind of a cheat. You know why I'm saying that? In other words, I don't want to substitute 40 for a sub 0 and 20 for a sub t. I want to call this 1/2 a sub 0 equals a sub 0 times e to the kt. And t is 710 years. that's when whatever amount you started with will be decayed down to half of the original amount. And the reason I don't want to know this 40 grams is because I don't need to know it. The a sub 0 cross off. So we can get the specific equation for this silicon 32 without knowing how much we have to start with. Now, for question B, yes, we need to know 40 grams are present now. But I would have preferred them to put that under question B and not included with A, because it makes it seem like you have to have that in order to solve A. You don't. You use this to solve for K. It's going to be the natural log of 1/2. And incidentally, whenever you're doing half-life problems, you're always going to have natural log of 1/2 in the numerator. Divided by 710 equals K. And now, how much will be present in 200 years starting with 40? You can go amount equals 40 times E to the, here's what I meant. I said you could write it like this. In other words, instead of approximating it with a decimal, I'm going to do that.
Mm-hmm.
And now, if I put that into my TI Inspire, I'm getting an exact answer that I can then round off. But you can wait and round something off at the end and not along the way, you're going to be protected against round-off error. And in this particular problem, he doesn't tell you to round it off to 4 decimal places. So this might be the preferred answer to A, is what I've written here, or what I've circled.
Mm-hmm.
All right. Sam, you good to go for this evening?
Yeah, I am.
Okay, and then you're off all next week, right? You got anything scheduled for next week?
I do not know.
I think I have some people here. Let me just take a quick peek. I can't remember if you were one of them or not. No, you're not. So it looks like it'll be at least a week. If you decide to schedule something next week, I got lots of time.
Okay.
Everybody's off school next week, so I don't have a whole lot of tutoring next week. Not on Thursday, I don't have time, but any other day, I'll have time available if you need help. Okay?
Okay.
All right, Sam. Talk to you. Have a good holiday.
You too.